Hello everyone. So in this video, we're going to talk briefly about one-dimensional motion. Okay, so an object just moving horizontally or just moving vertically. Now to start, what I'm going to do is I'm going to show you your big three. Okay, so what I've done here is showing you the big three of how we've talked about all year. D equals VIT plus 1/2 AT squared, VF equals VI plus AT, and VF squared equals VI squared plus 2AD. But then I drew a little arrow and I wrote down how they look on the AP reference tables. So for divot hat squared, D equals VIT plus 1/2 AT squared, you have X equals XO plus VO times T plus 1/2 AT squared. The O sometimes is pronounced not, whatever, or X0 plus V0 just means initial, right? So X equals your initial position plus your initial velocity times time plus 1/2 times your acceleration times time squared. Your VF equals VI plus AT turns into V equals initial velocity, VO, plus AT, and your VF squared equals VI squared plus 2AD goes to V squared equals VO squared, initial velocity squared, plus 2 times A times your change in position. So where you are minus your initial position. Okay, and that is the basic, those are the basic equations. Now, two basic ways to approach one-dimensional motion. One of those ways being horizontal motion. For horizontal motion, very simple, just use the values that they give you with these equations. It's nothing special that you need to keep in mind. They give you an acceleration, use that acceleration. If they give you a time, use that time, so on and so forth. What becomes tricky though is vertical. And it's not even so much tricky, it's just there's something you got to keep in mind. Okay, so the key thing about vertical motion is your acceleration. In this acceleration, you're going to use the acceleration due to gravity. Okay, that's the key piece, right? We're going to approach these problems as if they're in free fall. You know, if you're talking about, say, a rocket that is actively firing its boosters, then it's not going to be in free fall. Or if there's a string holding it up, as it's falling, not going to be in free fall. Right now we're talking about objects in free fall. Because it's objects in free fall where we can use this. If it's attached to a string, not so much. If it's a rocket being boosted up, as long as you have a bit more information, you can still use those big three, but just kind of adds a little bit to it. Anywho, so 2 basic ways, 2/3 basic ways you can look at vertical motion. You can have an object that is at rest to start, so it's just dropped, or it's thrown downward. Okay, so for dropped, thrown down, okay, it's dropped or thrown down. Since gravity, the acceleration due to gravity is always going to act down, right? Your acceleration due to gravity is always down. If it's dropped or thrown downwards, all of your other vectors will be pointing downwards. So your velocity will only be pointing down, right? Your displacement will only be down. In this case, you can keep your acceleration due to gravity positive. Okay, you can keep your acceleration due to gravity positive. Because if you threw a negative sign in there, they'd all cancel out anyways, so you end up with positive values. Okay? Now, if you have an object that is thrown upwards, that is where you have a little bit more to keep in mind. So an object thrown upward. Okay? Now, in this case, your acceleration due to gravity is still down. But now, your initial velocity is up. Right? Since you have one vector going up and the other vector going down, you've got these 2 vectors in the same dimension, vertical, pointing in opposite directions. The way we represent that is one of these 2 needs to be negative. Just for ease, since what we're used to is a Cartesian coordinate where your up is positive y and your down is negative y, is if you make your acceleration due to gravity negative, right? So you say make your g negative. Make g negative. Okay, so if it's thrown upwards, make your acceleration due to gravity negative, keep everything else positive. Your final velocity, if you're looking for up and then down, will also be negative, right? Remember, negative just tells you direction. So if you end up with a value that's negative, it's going down for a final velocity, for example. If you end up with a final velocity that's positive, it's still going up. Okay, so just keep that in mind while you're doing these problems. Now, just as a quick reminder, okay, your acceleration due to gravity is 9.81 meters per second squared. Okay, for AP, you can use 10. All right, so acceleration due to gravity is always 9.81 meters per second squared. For AP exam, you can use 10 meters per second squared. Okay, so that's pretty much it, right? Use the values they give you and plug those things in. If it's moving vertically, well, then you've got to use your acceleration due to gravity as your acceleration, and make sure you keep the direction in mind. Beyond that, it's fairly simple, just kind of multiplying or dividing a few numbers, and if you have the values, you should be able to figure it all out. Okay? Great. Till next time.